Pleasant morning to one and all. I'm Dr. Sumitra. I'm here to present you about an operating system. The basic introduction about the operating system and how does the operating system works. What are the computer system organization, architectures, and operating system structures, operations, process management, memory management, process management, productions and security, kernel data structure, computing environment, and open source operating system. So these were the topics we'll be discussing right now for the session. And what is the basic objective of operating system? What's an operating system? An OS is a main program in the computer that helps the user interact with the hardware. Think of it like a bridge between the user and the computer's physical component, like a CPU, memory, and the storage. And it acts as an interface between your hardware and the software. Computer system architecture. The computer system architecture is where it has the different parts of the computer system like hardware, operating system, application, and the user. Hardware is a physical part like CPU, memory, input and output devices. Operating system that controls the hardware and runs your application. An application is where the program you use like games, web browser, or the word processor. The user where a computer or a system people using your system, that is what the user is all about. So this is what the basic representations of the component of your computer system. And what does an operating system do? Making your computing easier and managing your resources runs your program. Making your computing easier, which means that let us use a computer without worrying about how your hardware works. And the manager resources, it decides how to share the computer resource like memory and processing power and runs your program. It executes your app and ensure they work efficiently. So this is how your operating system works. And the basic definitions of your operating system is where we call the operating system as a resource allocator, where it manages all your resources and it reflects efficiently fair and resource usage. And OS is also a control program where the execution of the program is prevent your error and improve the use of your computer. Was a basic definition of about your operating system. And we have a bootstrap program. The bootstrap program, which means that it is a program that helps you to load your power up or reboot your system, which is permanently stored on your random access memory, or read only memory, where we call it as an EEPROM, erasable read programmable read only memory. We often call that as a wireframe. And when the system loads your operating system on the kernel, it starts execution. What were the key, or we call it as a computer system organization, is where when one or more CPU devices or a device controller connects through your common bus, which provides an access to the shared memory, the concurrent execution of CPU and the devices will complete with your memory cycle. And we also having the basic operations of your computer system, like your hardware, as I told you about your hardwares and your CPU, memories, input and output devices, an operating system, application program, and your user. In a simple term, we can also state that these are the program which use means the hardware is an actual device and operating system makes everything to run properly, and the applications of the program you use to do the task, and the user or the people or a system that interacts with your system. So this is what your computer systems operations. And the basic common functions of your interruptions, which means that the interrupt where it transfers the control to the interrupt services routine generally through your interrupt vectors. which contains address of all your service routines. An interrupt architecture must have the address of the interrupted instruction and trap the exceptions of some software generated interrupted caused either by an error or the user request. Which I can also state that with a bootstrap program, which like the starter of your computer, it wakes up everything and get ready to work. When a computer systems carry out the basic common functions like a central processing unit, which is the brain of your computer that process all your information. And we have the device controller. The device controller is a manager that controls all the devices as your keyboard, mouse, or the printer. And we have the shared memory devices. The shared memory is a common workplace where the CPU and the device can store and access all your information. All these parts are connected through a common bus, which is like a highway that allows them to send and receive the data. So the CPU and the device work at the same time, which is concurrent execution to get their job done quickly. They often compete for access to share their memory, like the students taking a turns to use your library books. In a short, I can also state that it is a computer system which is organized so that all parts work efficiently by sharing your resources like memory and using a common connections to communicate. Hence, I can also simply state the interrupted functions with a simple explanation stating how your input devices and the CPU work together with the common functions, which a device controller or the interrupter, uh, the dev- each type of device like printers or the hardwares as a controller and is like a small manager that handles the work of the device. And we have a local buffer. Each controller has its own temporary storage space, which we call it as a buffer, where it holds the data while working. And the data transfer is where the CPU moves the data between the computer's main memory, RAM, and the device controller buffer. The device itself interacts only with the controller's buffer, not directly with the CPU. Hence, the interruption occurs where each device finishes its task like printing a page. The controller sends a signal called as interrupted to the CPU and says that I am done. Let CPU focus on other tasks in the same time. In a simple terms, I can also state that a device controller handles a device like a printer, and CPU and the device can work at the same time by using a buffer. The control signals the CPU when the device finish its work. The controller signals your CPU when the device finish its time. I hope you're clear with this concept of interrupt timelines and the basic introduction support operating system. Thank you.